Hi, everyone. I think I will just jump right in since we're a little after 1, or 1 my time, but let me get these full screen for myself. Okay, so my name is Nick Rosbrook. I work at Assured Information Security, and I'm going to talk about Go and libxl and the work that we've done over the last year or so since the last Sun Summit, getting some Go bindings generated. So I'm just going to walk you through some of the details and using the IDL in general. So I'll start with a brief overview of CGO so you can understand the basic mechanics of how Go calls into C code. And then I'll spend the bulk of the talk covering the Go generator that we worked on. And my goal with this is to kind of show you details of what we faced generating Go code specifically, but also hopefully to give people who are not familiar with the libxl IDL a little bit of insight in how it's used, so that hopefully if anybody wanted to generate bindings for another language, that this could be a useful tool. And then I'll talk a little bit about where the Zenlite Go package is today and future work that we have planned. So as I mentioned, CGO is just Go's interface for calling C code. It works by giving you this pseudo function C that as members of the package has symbols that you would expect to see in C based on whatever header files you include, and it even allows you to define your own extra functions if necessary in something called the Preamble. And I have a quick example. So this is from the Zenlite Go file. You can see at the top, there's this block comment here. This is called the Preamble. We set some linker flags, and we can also include any files that we need. In the actual version 2, which I omitted here just for brevity, but we also do define a little bit of our own C code to help handle some other edge cases, so you can do much more than is shown there. I don't like these transitions. All right, and then the example here is this wrapper for the named DOM-ID function. You can see we have a Go style function signature here, where we're defining a method on context type, which is a Go wrapper around libxl context. And we're using the multiple return value feature to signal an error or return a DOM ID on a success case. And right here, you can see we declare a variable of type c.uint32t. So that is coming from the C pseudo package that I mentioned, but now that's a type that we can use in Go normally. And we'll convert, so these transitions are quite slow, the string that we are given and convert it to a C string. And because that we allocated that in from Go space, it's our job to free that when we're done. So we'll defer that free. And then finally, we can just call libxl named DOM-ID with the C types that we just converted, and it's very straightforward. So it's really, CGO is a really nice mechanism because it's almost one-to-one. There are a few nuances along the way, a couple that I'll get into, but it's really overall pretty straightforward. Okay, so now on to actually making the generator. Some goals that we have are to safely marshal data to and from C. And this is really the bulk of the work because, as I just demonstrated, the CGO really helps you a lot. As long as you can kind of do type conversion and you know how to handle the data types that you're working with, the function calls and everything else is very straightforward. We want to provide an idiomatic Go package so that any users of the package feel familiar with it, and it follows good Go conventions where appropriate. And we want to properly handle libxl conventions as well. last year when I spoke on this topic, we were originally investigating using a tool called forgo that kind of parses C code and generates some Go bindings, and it generally works. But one of the reasons that the IDL is so nice is that we know exactly the conventions we need to use and specific things that the data structures tell us. For example, the length of an array can be leveraged here, and we won't have any of that information being misused or subtle bugs. So the libxl IDL provides Python classes that you use to mock up data types. Examples of that would be the enumeration class, struct, and keyed union. And they look like this. So you can see there is an example of defining an enum. You just give it a name, specify a list of tuples that has the value and the name of the enum, and then a struct is shown there below. And it's very similar. You give it a name, give it a list of tuples that represent fields, the field name and the field type. And as you can probably notice there, the field types are actually also types that are defined elsewhere in the file. They're not just symbolic. But anyway, so it's pretty straightforward to kind of define a type this way. And they're also very easy to use because when you use the IDL Python package for your generating code, you're just working with a Python object at this point with these attributes. So in practice, the top level types that you need to deal with are enumeration, aggregate, and built-in. When dealing with structs specifically, there's also other types you have to deal with when they're a struct field. But as far as top level types, these are what you need to worry about generally. In the case of an enum, Go does not support an enum type, but there is a well-defined pattern that is used everywhere where you make an alias type to some integer type, usually uint32, and then you define a const block, maybe using the iota, or you can do it explicitly. But and that has the effect of creating an enum, because Go will still require, like if you use that type in a function signature, that it's of the correct type. And for built-in functions, we write these by hand, but the generator still needs to know when we encounter a built-in type, because we need to know what's available for type conversion. Like some types might be able to just be converted kind of explicitly in Go terms, but other types might have a marshalling function associated with them. Examples of these are libxl, UUID, Mac, and Deferring. And so this code snippet is kind of an example of what the Python code looks like when working with the IDL. So this is, as you can see in the signature, this is the function for defining a struct. So that we do is, or in this case, that a struct or an aggregate type has an attribute called fields. So generally the code will look like this, where you're iterating over the fields given, and if the type is named, then it's going to be either an array, or or it might be some other basic type like an int or a string. And so in those cases, it's very simple. We can just kind of format the type name in a Go specific way and write it out directly. And another case would be a nested struct, but as you can see, it's very easy. Just use the isInstance function to kind of work through identifying the types that are provided to you. And I think a fun fact about this one, if I remember correctly, there's exactly one instance where this actually comes up, where there's a nested struct in libxl. And finally, there is the keyed union type, and that requires some special casing in Go that I'll cover soon. And this is just some example output of what you get given the previous IDL definition that I showed earlier for C pool info. All right, so problem, Go does not have a union type. Just CGO just treats unions when it sees it as a byte array. And if you're not familiar with the concept of a keyed union, I included a snippet here to show you straight from libxl. So we have a key for the union, which tells you how to access it. And then the union itself will contain a struct for each case of that key. And so here we see we're in libxl domain build info. So we've got the union is for HVM, PV, and PVH specific fields. And so the solution to this in Go is that we kind of have to recreate a union to be able to support the same functionality. And there's an idea from gRPC originally. In their protocol buffers, they support a message field of type 1 of, which for all intents and purposes is a union. And in their generated code, they do a similar trick to what we have here. So here you can see this field in our Go version of domain build info. We have the key above just like normal in the type field. Then we have this type union field, which is of type domain build info type union, which is a mouthful. And all that is an interface with one method is domain build info type union. And so what that allows us to do is define all of these special case structs that would be in the keyed union normally, the PV and PVH HVM specific structs. We can define them as their own first class structs in the Go package and just give them a no-op is domain build info type union. And so that means that any one of these structs then will be valid. It satisfies that interface that's needed in the type union field. So it's kind of a neat trick to get union functionality in Go. And it's a little bit of a mouthful, as I mentioned already with these types, but it works pretty well. All right, and then, so the next thing that we had to worry about is marshalling functions. Basically, as I mentioned, we really only need to worry about safely handling data handoff between C and Go. And so for each type, we want to have a constructor so that package users can just call this function and not worry about anything that's going on under the hood with CGO and libxl and init functions. And we need a from C and to C Marshal function. And this is where we also want to worry about following libxl conventions, such as keyed unions, array sizes being specified in an extra field. These functions are aware of the libxl dispose functions. So in error handling, we want to make sure that gets cleaned up and we don't leave anything lingering, and then also libxl init functions. So many types are easily converted from C. The Go has type conversion. There's no casting or like type coercion, but conversion can be done explicitly in these cases. And because the Go compiler knows about C.UN32 types, for example, and that TSC mode is just an alias for that type, and so it's a valid conversion. Same for here, and in case of strings, the CGO provides us with some helpers to do this, so it's all pretty straightforward. And others are a little bit more ugly. So in the case of arrays, there is this kind of nasty trick here. Basically what this is doing is taking an unsafe pointer to the array in the C type and converting it to a pointer array of massive size, and then slicing it here with the n, which we get here from the num v numa nodes field. And it's pretty gross, but it doesn't actually allocate an array of that size. It just uses that as the type so that the type checker is satisfied. And then we can just iterate over that. Because the point of doing that initially is that we have something that we can iterate over and then call our marshalling functions on each element of the array, like there. And going the reverse way is pretty similar. Types that are easy are still easy. And types that are not so easy are still gross. So I have to do this malloc first, and then we kind of employ the same trick, the giant array pointer cast or conversion, and iterate again, calling the marshalling functions. And I think one of the last bits on doing these functions is handling errors that occur. I mentioned we can use the dispose function here to help us in every type. So in the 2C functions, you'll see this defer statement used here. And if you're not familiar with Go and the idea of deferred functions, what this does is, this highlighted bit right now is our return type for this function. And we've given it a name, error, ERR, and because of that, deferred functions, that variable will be in the scope of this deferred function, which is going to be called immediately after the outer function returns. So when we get to this bit here, this error that we're examining is the value that we're going to return. So we're checking right here that if we're returning an error that's not nil, so we encountered a problem, we're going to clean up this C type that we were working with. And what these functions give us is a good foundation for the package in order to generate wrappers. It makes it very easy because it gives us a good way to work with CGO in a way that is basically just like writing C code, because we have all of these marshalling functions. We can take the Go type of whatever function we want to call in libxl, convert it to C, and the compiler will be happy. And as I mentioned, we can do constructors that look like this, so that any package users will get a type that is the init function has been called. So we know it's going to be the same way as if you were using libxl to initialize, and the user doesn't have to worry about any of that. The state of the package today. So since last year, we've added full support for Go type generation and the marshalling functions that I just went over. We began support for managing domain lifecycle. Domain creation is supported. Needs a little work for reaping domains after shutdown. We've added some additional wrappers for libxl functions, but there's still a lot missing. The Go module is Go Gettable now, so that URL is you can use that as an import path in your Go package, and it'll like initialize the Go module, so it is aware of the Go module ecosystem. And the documentation, as a result of that, documentation is auto-generated and based on package Go dev, which is the kind of successor on the way of Go doc. Build support has been added, so Go tools will be built by default if you have a high enough version of the Go compiler. and for 4.14, it will be in the experimental state. The way that I personally am using these bindings is in the redctl toolstack, which is a toolstack for Redfield, our client virtualization distribution. And so we're starting to, I have a branch where we're experimentally using the bindings as a way to exercise them. And the part that I'm really excited about is having a unified type definition with libxl. So we use gRPC for our RPC API. And today that requires us to kind of redefine the types that we want to use using a gRPC protobuf. But this will allow us to use the types that are generated directly from the libxl IDL. Finally, future work is going to expand the API coverage in general, but especially look at domain lifecycle management. So we actually just had a design session on this and came up with some plans for expanding the libxl IDL. So we're looking to add function classes similar to the type classes that exist today. So we'll be able to use the Python objects in a similar fashion to generate function signatures and wrappers. Stable home for the Go module is something we also discussed. So we'll be looking to figure out effective ways to have the Go module housed in its own repository. And want to keep refining the state of the binding so that we can hopefully get them declared tech preview next and keep going from there. And I think that's all I have. So yeah, I'll be open to questions. Before I do, I just wanted to give a thanks to George Dunlap for all of the help with all this work over the last year, and to other tools maintainers as well, Ian Jackson, for his support. So yeah, but I will take any questions. Right. All right, well, if there are none, I will just mute myself, but I guess I'll hang out in here until the closing remarks in a little bit.
Well, we could ask, so people that hear the session, are you familiar with Go, or is there another language you were thinking about writing bindings for? Or are you just here because, just out of interest?
No, the goal is not to rewrite libxl. The goal is to be able to call into libxl directly from Go, rather than having to do something, for example, calling XL from the command line or via like OS exec in the Go case. Because right now, the tool stack that I mentioned, redctl, anytime we want to do anything with libxl, we have to call XL from the command line, and that has a lot of disadvantages. So this would allow us to do things directly.
Yeah, the idea here would be that you can write, I mean, it's actually quite simple to write, domain creation stuff or just tools like that either a larger tool or a number of small tool script-like things that you can use to just control or get information about the system in a way that's more efficient than running XL. So right now, a lot of people just like fork out and run XL. They might do XL list and then parse the output or all kinds of crazy stuff like that. And it's just like, well, you don't need to do that. You can just, if you have a modern, easily compilable language like Go, garbage collection and stuff like that, then you should be able to write these little, tools in Go and just compile them and run them. Yeah. So libxl is always just C is a much easier language to write other things on top of than basically any other language. Why not Rust or OCaml? Like you could do that. So there already are actually OCaml bindings for libxl, very, very old. They don't use the IDL, and they're kind of not used very much, and they're not very tested very well. So I think if someone wanted to use OCaml, then they might use the work that Nick has done as inspiration for doing a good, for generating the bindings. Same thing with Rust. It's just, well, I mean, I don't know why, I happened to learn Go when Rust was still, before 1.0. So I haven't learned Rust yet because Go is fine for me. I may learn it someday. There's lots of people who love Rust and say, hey, we want some Rust bindings. Then again, the work that Nick has done should sort of, it'll be kind of not paving the way, trailblazing, so it should be easier to find out now if someone wants to write similar kinds of Rust bindings to what needs to happen to make that work. So for one of the things Nick mentioned, for instance, is we're going to be right now if you want to write a wrapper for the libxl functions, you have to do it manually. But a lot of that is just really, really repetitive work. It's like if you can read the type interface, you can just exactly what the wrapper needs to be. And so we're going to be working on adding the functions into the IDL, such that those can be auto-generated. The wrappers for those functions can be auto-generated. And then that work will also be useful for other things like Rust and OCaml, so that then you can just write Rust wrapper functions and OCaml wrapper functions in the same manner. Does that answer your question, Nicholas? Yeah, so if you want to do Rust, then we'd be happy for that. That's the more the merrier.
Yeah.
Okay, great. Well, I'm going to switch to back to the main session. Thanks, Nick.
Cool. Yeah, thank you, George.
Yep. Bye.
All right. Thanks, August. So wait for. Not that I know of with XAPI, but yeah, I'm gonna head to the closing remarks as well. So thank you everyone for coming.